My name is Robert Haskins. I'm Director of Information Technology for ZipLink. You'll notice I did not put that on my slide. I was afraid that you'd throw me out if you knew I was in management. But I have been a systems administrator for about 10 years prior to becoming a member of management. I have to say that this is maybe I haven't gotten out enough, but I'm surprised by having 3/4 of the audience looking at porn. I mean surfing the web, but it's an interesting fact of NANOG. Before I get started here, I'd like to take a couple quick surveys. I could see a show of hands of people who work with Unix on production systems at some point during the day. And how about people who work more than 50% of their workday on production Unix or NT systems? That's more than I expected. I'll start off here with a quote. The article that this quote comes from I absolutely love, and I have a copy of it in my office. I know you're all anti-spam, but this is such a great quote that I want to share it with you. As I said, I have a copy of it in my office ready for senior management when they come in and say, can we modify our acceptable use policy because we have a customer that doesn't want to abide by our strict terms. And so I actually brought a copy of it with me here. I whip the copy out and I highlight the interesting parts and hand it to them. In any case, it's from Interactive Week, the March 6, 2000 issue. It's entitled Aegis Runs Aground. My apologies to my friends at Aegis. It's about them filing for bankruptcy. It's by a gentleman by the name of Max Metanikov. I hope I'm pronouncing that correctly. Talked about the president, Phil Lawler, president of Aegis. Lawler opened Aegis to unsolicited commercial emailers and only relented after a walkout of key technical staff and a crippling hack attack in 1997. Now what I want to know is, did the key technical staff walkout happen before or after the hack attack? Here's an outline of what I'll be talking about today. When it comes to the subject of spam, technical people tend to throw their hands up in the air and say, there's not really anything we can do about it. I'm not one of those people. I firmly believe that we can do something about spam. In fact, companies like ZipLink have to do something about spam. If there's anyone here from UUNet or Savvis, our upstream providers, they'll tell you the number of occasions that they've threatened to shut us down because we didn't act quickly enough on spam. It's a major problem, and we have to do something about it, especially those of us who are wholesale dial providers. Now, my friends in marketing will kill me when I say this, but we are a wholesale dial-up provider. That is our core business. Some ways you can define yourself is by who your competitors are. Our competitors are the likes of Navipath, Aegis, and some other ones. I can't think of some other ones. Our customers fall into 3 categories. They're free ISPs, information appliance vendors, and small ISPs. The bulk of our spam does come from small ISPs. That's our problem. In terms of who our customers are, we have Spinway, First Up, and WebTV as an information appliance vendor. As I said, we can be a source of spam like most wholesale providers. And our problem, how do we come up with an effective way to block outbound spam? Goals are always easy to come up with when you're coming up with for a presentation. But if I were to sit down and put together some goals prior to implementing this back in December, I would have thought that the ability to block at least 50% of outbound spam would be a worthy goal. In fact, I think we can, I'll go out on a limb here and say I think we can block upwards of 80% of outbound spam with this solution. Another requirement is that it has to have little or no impact on the ISP and the subscriber. This gets into why we have to use layer 4 switches to redirect the SMTP connections. I'll talk about that in a minute. have to be able to exclude certain domains. Some folks like NetZero are doing a fantastic job. Keep it up. They're blocking spam. It's got to be configurable and scalable. I think we've achieved that. We have to have a low impact on our radius servers. We can't be causing our revenue to go into the toilet as we're blocking spam. I think we've achieved that. And it's always nice to utilize freely available software. Now, it's interesting how this project came about. I had this idea about a year ago, and when I mentioned it to our president, Chris Jenkins, he basically poo-pooed it and said, we don't have money for it, blah, blah, blah. We're too busy with our IPO. So about 6 months after that, in December of '99, he got an email from, or queried from the chairman of our board of directors, Eric Zach, asking why had one of his friends gotten spammed from a Zipline customer. So of course, Chris comes running to me and says, what are we doing about spam? And I said, Chris, remember that idea I had? So that's when he opened up the checkbook, and $80,000 later, here I am. There are surprisingly few existing solutions for spam. The most interesting one, from my perspective, is something called Blackmail by Ken Hollis and James Murray. We took a look at this. It does sort of header-based checking. It checks for existence of a from domain, does some other things. It's a great package, but it's focused on the problem of inbound spam. I included Snapd and SMTPD, which really aren't spam solutions per se, but you can use them to assist in blocking spam. They're more proxy solutions for proxying through a firewall. There's Brightmail by Brightlight Technologies. Fantastic job these guys are doing. It's a service that you subscribe to. They have a NOC that receives spam, generates rule sets to identify the spam, and applies these rules to filters that exist in mail relays at your site or your infrastructure. It's a great solution. Again, if you host pop boxes or you're a retail ISP, it's a great solution. RAS filters. RAS filters is a great way to block spam. Our issue with RAS filters are twofold. First of all, they tend to be difficult to manage. When you have upwards of 500 filters that you have to manage, it's a lot of filters to manage, especially when you're using the Bay Network's 5399 equipment that doesn't manage filters very well. Second problem is one of performance. We can't be having our inverse reports look bad on us. So the reason for the bad performance is the processing power that the blade has to do in order to process those filters. They're workable for your big customers. For example, we'll still be using them with the First Up and the Spinways of the world. But when we're talking about 500 small ISPs that use your network, it's not really a workable solution. There's Maps. Great job, Paul, keep it up. Maps is a great thing. However, it's not really focused on the problem of wholesaling dial-up ports. How many of you have heard about Hashcash? Anybody? One or two? Hashcash is sort of a digital postage solution, not really involving any money, but it does block spam. The problem with it is it requires changes to clients, mail clients, and that's unacceptable. No solution met our needs completely. As I said, most solutions are focused on the problem of inbound spam only, not on outbound spam. That's what we're trying to solve. No solution incorporates the idea of message metering. I was bouncing around the Maps pages, and I don't know why I was looking at the how to sue Maps, but I somehow ended up there. I went back to look for this link, I couldn't find it. In any case, Paul mentions the idea of message metering, one mail message per minute. So there is a reference out there on message metering, but there's no solution that I could find that actually incorporates this. And that is indeed our solution. or one part of our solution, is to allow the end user to send only X messages during Y amount of time. Seems to me to be a pretty good definition of spam. Here's a 50,000-foot view of our solution. The top line shows Radius records getting fed into a SQL database. In our case, we're using Oracle. The bottom line shows the path of a mail message as it goes through our mail relays. Pretty simple. The user sends a mail message out, hits a quota checking mail relay. The mail relay executes the quota check and then forwards it to the recipient if the user has not exceeded their mail quotas. We wrote the code for the Radius to the Oracle database portion of this from scratch. It's about 800 lines of C code. Basically, it's a bunch of Oracle function calls to feed this data into the Oracle database. Very simple stuff. It reads Radius accounting logs from our Radius servers and dumps them into an Oracle database. Now, it's important to note here, if you don't want to do the per user or per domain quota checks, you can get by having this. You don't have to utilize this function. If you're an enterprise, this might be a solution. You could just allow IP address X to send, Y number of messages. It does have low overhead on our Radius servers. We have an Ultra 2, two-processor Ultra 2, and a single processor Ultra 5. Both have about less than 5% overhead. And there are additional fields for message counts and limits in a separate table. A little more detail on the mail relay functionality. User initiates a mail connection, a mail message. It hits a layer 4 switch. This layer 4 switch can be at one of two different points in your network. It can be either A, at our POP, at your POP, or B, it can be at a central point in your core of your network using L2TP tunneling to tunnel terminators which have this layer 4 switch on the other side of them. Now in our case we have about 60 POPs, so if you utilize option A, we have about 60 layer 4 switches that we have to manage. So I think we're going to go down the path of the L2TP tunneling, but that has its own whole host of issues. One nice function of the layer 4 switch is it allows us to do other things like caching, filtering content, those sorts of things. So it's not just layer 4 switch is not just a anti-spam solution, but it's more global than that. Layer 4 switch takes that mail connection and redirects it to our quota checking mail relays. If it passes the quotas, it gets sent to the customer mail relay, the ISP's mail relay, and then forwarded on to the recipient for final delivery. We selected the Obtuse Systems Corporation code over the TIS toolkit for two reasons. The first is SMTPD, or the Obtuse code, runs a BSD license, which is less encumbered than the TIS toolkit. Second reason is SMTPD runs as a daemon and not out of INetD. There are performance benefits of running as a daemon as opposed to out of INetD. SMTPD does three things: verifies the source IP address is within the zip link range. It executes the quota check for that user or that domain or globally, and then it forwards the message to SMTP forward, which is part of the Obtuse toolkit. SMTP forward simply relays the message via SendMail to the ISP customer for final delivery. Now it's important to note here as well, we made no changes to SendMail. I leave it to Eric Allman to hack SendMail. Sort of the buttons and knobs that we have to adjust. We have three different levels that we check. As I said, we have the user level, the domain or realm level, and then the global level. And for each of those levels, we have two settings, two number of messages per time interval settings that we can check. The intent here is to have sort of a less time interval and a higher time interval. For example, you might have 100 messages in an hour or 1,000 messages in a 24-hour period as your two levels. As the quota check is executed, the first time it hits an existing quota, it exits. So if there is a user level quota set, the check stops at that point. If there's no user level quota set, it drops down to the domain or realm level quota check. If that's not set, it drops to a global level, which is across the database. Hopefully there's a global level set, but if there's not, it defaults to the settings which are on the slide there. It's important to note that these are simply compiled in defaults. We'll probably end up changing those, but that's what we've compiled into the SMTP code. The error message that the end user receives is a 450, no quota exceeded message. The reason we picked a 400 series message over a 500 series message is that it's easier on the legitimate user attempting to send a message and harder on the spammer. A legitimate user, a 400 series message will requeue the message for delivery. So a legitimate user will have their mail delivered the next time the quota is reset, hopefully 10 minutes or whatever. In the case of a spammer, there are 10, 20, 30,000 messages they have queued up. Will hopefully back up their PC and cause them all sorts of consternation, which is a good thing if you ask me. A few more miscellaneous points on the mail relays. Users who have large queue lists who legitimately send lots of messages out can be accepted from this policy. This is done by increasing the per user quotas, and this is the ISP customer's responsibility to do this through a web interface. Obviously, the ISP can allow someone to spam, and if this does happen, we'll pull their ability to change their users' quotas, and we'll do it for them. Failure mode is always important. Our failure mode is to allow mail to pass through without executing a quota check. I don't know why there's a failure mode. We all know that Oracle never dies. There's problems with everything. This as well. Still requires an acceptable use policy. Tommy Shikawa, a colleague of mine who's here today, mentioned when I gave this talk back in Lowell that it would be a good idea if ISPs actually wrote limits into their acceptable use policy. For example, you can't send more than 1,000 messages a day or something like that. That's a good idea, I think, as a general rule. As I said, the ISP changes the default quotas, the subscriber can still spam. There's no way to allow individual subscribers to use a third-party mail relay. Now, this is an example of this would be a business customer, an employee of a business that utilizes the ZipLink dial-up and they want to relay mail through their company's mail relay. That's not currently possible. Not sure how big of a problem this is going to be, but it is an issue or a possible issue. This does require a mechanism for redirecting all mail traffic to a central point. This is the layer 4 switch I talked about. This is the toughest problem to solve for us. I think the biggest reason why no one has done this is the possible First Amendment ramifications. I'm sure my friends at the Electronic Frontier Foundation and the Center for Democracy and Technology will be very interested in this when we go to deploy this. All I can say is wholesale dial providers have to do something about spam. We are pro First Amendment, but we have to do something about unsolicited commercial email. A few references, things that I've talked about today. My webpage has a few anti-spam links on it, as well as the slides from this presentation and my notes. I would love to hear any feedback you may have on the solution, comments, questions, etc., through email. At this point, I'd like to say thanks to NANOG for giving ZipLink the opportunity to talk about how it's trying to stomp out the scourge of spam. I'll be happy to take any questions or comments you may have at this point. Howdy.
It's always been the position of cause in every ISP I've ever known that the First Amendment has absolutely nothing to do with an ISP, as the First Amendment talks about the government's inability to stop you from saying anything you want, and we have nothing to do with the government. You can block any spam you want, you can block any email you want. The only thing you have to worry about is what they paid you to do and whether you're contractually obligated to pass that email along. It has nothing to do with the First Amendment.
Yes.
Your definition of a message, are you counting the envelope 2? Each entry is an envelope, 2 line is one more message.
Yes.